The awakening Hayli Gubbi eruption, the event on November 23, 2025, was a geological shock because the Hayli Gubbi shield volcano had been dormant for an estimated 10,000 to 12,000 years, marking its first known eruption in the Holocene. Current geological epoch. 1. Geological significance. The why. The story must begin with the Afar rift. Tectonic setting. Hayli Gubbi is located in the Afar region of northeastern Ethiopia, which is part of the East African Rift System. This is a crucial region on Earth where three tectonic plates, the Nubian, Somali, and Arabian plates, are diverging, pulling apart. This is called a triple junction. Rift dynamics. The crust here is being stretched and thinned, allowing magma from the underlying mantle plume to rise easily. This process will eventually split Africa and create a new ocean basin over millions of years. The eruption mechanism. Unlike typical shield volcanoes that often produce mild, fluid lava flows like Erta El nearby, Hayli Gubbi's eruption was surprisingly explosive, classified as Sub-Plinian. Magma type. Researchers suggest the eruption involved more viscous, silica-rich magma, like trachytes or rhyolites, which can trap significantly more gas than fluid basalt. The sudden release of this trapped pressure caused the massive explosion. A precursor activity, uplift of a few centimeters, was detected by the Center for Observation and Modeling of Earthquakes, Volcanoes and Tectonics (COMET) during November 13-19. Suggesting magma was rising beneath the surface before the main event. Structural change. The large explosion excavated the previous summit cone, enlarging the main crater from about 330 to 390 wide, and creating two new, smaller craters nearby. 2. The global reach. The how far. The high-altitude plume had an almost immediate and far-reaching international impact, demonstrating the interconnectedness of Earth systems. Wash plume and trajectory. The gas and ash plume was massive, rising between 10 to 15, 32,850,000 feet into the atmosphere, reaching the upper troposphere and even the lower stratosphere. Transcontinental drift. Driven by strong, high-altitude winds, jet stream, the plume traveled over 4,000 in 48.72 hours, passing over the Red Sea, Arabian Peninsula, Yemen, Oman, Arabian Sea, Pakistan, and into northern India, Gujarat, Rajasthan, Delhi, before continuing toward China. Aviation crisis. This was the most significant immediate consequence outside of Ethiopia. Danger. Volcanic ash is made of tiny, abrasive particles of rock and glass. This material can melt inside jet engines, solidify on turbine blades, and cause engine failure. It also pits windscreens and clogs air systems. Disruptions. The Volcanic Ash Advisory Centers (VAX) issued warnings leading to the cancellation or severe delay of dozens of international flights across India, Air India, Pacific Air, and along crucial air corridors between Europe, Africa, and Asia. Detection. Crucially, volcanic ash is invisible to standard onboard weather radar, necessitating real-time satellite and ground-based tracking by bodies like the India Meteorological Department (IND) and VEX. 3. Local human impact. The WHO focusing on the sparsely populated Afar region provides the human element for your video. Eyewitness accounts. Residents reported hearing a loud sound and feeling a shock we've described as like a sudden bomb had been thrown. Local fallout. Extensive ashfall blanketed the area up to 40 m away from the crater. Livelihood threat. The Afar community relies heavily on livestock herding. The thick layer of dark brownish ash contaminated grazing fields and water sources, posing a direct threat to the animals and the community's primary economic activity. Medical teams were dispatched to address health concerns related to inhaling fine ash particles. This eruption is a critical case study in how deep earth processes in an isolated region can quickly translate into global economic and logistical challenges.